Hello friends, welcome to my channel. Let's have a look at problem 721, accounts merge. So in this video, for this problem, we're going to share a method or solution based on disjoint set data structure. So actually, if you notice the problem title, accounts merge, and then read through the statement of the problem, actually this merge corresponds to the union in the disjoint set data structure, right? So we are going to union the accounts according to some criteria. So here, what we are going to union are the emails, because the emails identify unique accounts. So here, the main idea is the following. So we are going to use the find method to create cluster or create group, and we use the union method to merge email strings. And after we cluster the emails, we just need to build the return format verbosely. So one assumption in the problem is that the accounts can be returned in any order. As such, we could use a set data structure to record the accounts or account we have already built to exclude repetition. So with that said, actually we can interpret this problem as a standard application of the disjoint set data structure, which the union method in this data structure corresponds to the logic of the problem. So in this video, our plan is as follows. First, I'm going to implement the disjoint set data structure. So here, the two main methods are find. We're going to implement find with path compression. So in this video, I'm going to implement the path compression using an iterative way. The other method is the union by rack. So with these two methods, we also implement another one, which is called getComponents. Here, the getComponents method is, on one hand, to aid the logic or the solution to this problem. On the other hand, is to help get more meta information to gain better understanding or gain better feeling for the problem. And after this implementation, we're going to apply the data structure naturally to the problem setting. So before we do the implementation, so we suggest that you try Leetcode 305.839 using essentially the same code, or you can check out other videos in the Unified playlist. So there are problems which are slightly harder or slightly easier than this problem. So first, I'm going to implement the disjoint set class or the solution class, so that the disjoint set data structure can be used in general. So let's do the implementation first. The class, let's call it disjoint set. What we are going to do is the two main methods, find and union. Let's first look at the initialization. So I'm going to initialize a root, empty dictionary at the very beginning, and rack. It's also a empty dictionary. And so basically, I would not use an attribute like in previous video called in clusters, because it's not relevant directly in this problem. So with these two attributes, we're going to move to the implementation for find method. So for the find method, we can accept a string. So here in this problem, what we are going to merge or find is the emails, or the string corresponding to the email. So here as string corresponding to the email. So in this problem setting, first I'm going to look at a case that is as not in the data structure yet. So if s not in self root, so in this case, I'm going to add it to the data structure and make itself the root of itself. And then we're going to set the rec of this s to be 1, because currently the cluster containing this string s is of size 1. And then we're going to return s in this case. Otherwise, we're going to make a chain of calls to retrieve the roots of the current string s. So for that purpose, let me first initialize a variable called path. I'm going to implement path compression using an iterative way. So basically, while s does not equals to its root, then we're going to add this s to the path, right? And then we're going to set s to be its root. After we exit this while loop, then we're in a state that s and its roots are the same. So then we're going to do the path compression here. So what we want to do is that for the node or string in path, that's for node in path, what we are going to do is we set the root of the node to be s. And then this finishes the path compression step. Then we're going to return the s. So that's the find method. So now let's look at the union by rec method. Union, so self s1 and s2. So here I'm going to use union by rec. Right here, what we want to implement actually find with path compression. So here is in an iterative way, right? So what we want to do in this union operation is that we first locate the representation of s1 and s2. In other words, we locate their corresponding clusters. So if they are in the same clusters, we do nothing. Otherwise, we merge the clusters according to the rec. So let's do this first. So first let's find the root 1, root 2. So that is self find s1, self find s2. So root 1 and root 2 are the representations for the clusters containing s1 and s2 respectively. So we just need to check if root 1 does not equals to root 2. So in this situation, we're going to do something. So we need to check the rec and then use the rec to merge them. So if self rec, so root 1 is greater than or equal to self rec root 2. Then in this case, we're going to merge the cluster containing s2 to that of s1. So this corresponding to set the root of root 2 to be root 1 and increment the rec of root 1 by that of rec 2. So in the other case, we're going to do the same thing, but in the reverse direction. So we are going to set the root of root 1 to be root 2. And we're going to increment the rec of root 2 by root 1. So this way, we finish the implementation of union by rec. So per the problem here, we're also going to implement one method called getComponents or getClusters. So this is actually a very routine one. So I'm going to implement the empty dictionary and then going to iterate over the data structure root attribute. So for key and v in self root items. So first we are going to locate the root for the current v. So or you can think of this v as an email, right? So once we do this, we're going to check if the root already in the dictionary or not. So if root not in D, we're going to set the value corresponding to this root as a single element set. Otherwise, we're going to add the current key to the set. So that's about it. So we are going to return D. So D is a dictionary representation of the clusters, with the key being the representation and the values, the emails or the nodes within that cluster. So with that said, I guess we finished the implementation of the disjoint set data structure. So it contains 3 methods in the current implementation. One is find with path compression, and in this video we implement this method using an iterative way. And then another is a unit method we implement using the information of the recs. And finally we implement a small function called getComponents, which basically help us track or retrieve the clusters. So with that said, let's look at the problem solution. So this actually is sort of routine. So first I'm going to instantiate a disjoint set data structure as we implement above. So let's copy this in order that we write it correctly. Yeah, it's right. Disjoint set. Let's copy this maybe for safety. So and then we are going to scan or traverse the account. So for account in accounts, notice that the first element in the account is the name. So what we are going to find and merge are actually the emails. So later, after we do the unit operations, we're going to come back and use the name information. So first account is going to be account 1. So then what we are going to do, this is the first email in the account ACC. Then if length of ACC is just 2, in other words, it only contains 1 email associated with that name, then we're going to find DS, find this first email, ACC, first account. So this is actually an email. Actually we can do a check. So if first account not in DS root, so we do this. So but we can, if we do not include this if statement, this line is still okay. So this is the one case. Otherwise, so if it contains more than 1 emails, so because these emails correspond to a same person, then we are going to merge those emails with the one already in the data structure. So for other account in account, the remaining ones, so what we are going to do is DS union. So with the first one, right? So first account and other account. So that actually finished the procedure of merging all the accounts. So let's call this one step 1. Merge accounts. So with that done, actually the remaining thing is to build the output. So this actually sort of routine. First, I'm going to initialize a result, which is going to hold the accounts. The accounts consist of name and emails. And then also we want to use a set to monitor the account we have already built to avoid repetition. So once it's done, so we're going to traverse the account. So what we want to do is that we are going to check if the first account is already in the data structure, and also if it's already checked. So basically it's a if check if the email so also I need to first get the clusters, let's call components, equals ds get components. So we're going to check if it's in components, and acc1 not in checked. So in other words, we haven't added this account to the result. Then we're going to build this result and append to the result list. So we're going to append this. What we are going to append is nothing but the let's see, the format. So this is the output, right? So we're going to append account, so 0. So this is a name, right? Then so we're going to use a concatenation of list. So we're going to add a sorted, so components. So let's see, sorted components corresponding to this acc1, right? So let's see, we account sorted so I'll make this one a, yeah, that's the right braces. So then we're going to update the checked, so add this current account 1, current email. Then that's about it. So this second step basically is a routine to build the output format for this problem. Then we're going to return the result. So that's about it for the full code. So now let's do a special case check. Yeah, it passes example 1. So now let's do a generic case check. No attribute roots. Let's see where we are. Disjoint roots, self roots. So here I'm going to use self root. Let's check it again. Yeah, it passes the generic case. So I guess that's about it for this problem. But here, if you want to get the information for the components, in order to not confusing on how to build the output, you can print out this component. Components. Let's see. Yeah, so that's the clusters. So here, this 3 forms a cluster, and this one itself, the Mary email, forms another cluster, and the Johnny Breville forms another cluster. So with that said, I guess that's about it for this problem. Thank you very much.